Welcome friends, Dr. Jim Daly here from Astronomy for Change. Back about 4 years ago, we published an article entitled, What are the 5 Brightest Stars? Alright, since then, 4 years ago, we've had many hundreds of hits on that article. It's a popular article, many people have read it many times over. And what we're going to do at Astronomy for Change here is continue that idea, that theme, and expand it to include not 5 stars, but the 10 brightest stars in the sky, some of which are readily seen right now in midsummer months, going into the fall, late July, early August. It would seem that many people are interested in this topic, and we're going to continue continue and expand that idea, that theme, expand the list to not 5 stars, what are the 5 brightest stars, but the 10 brightest stars. All right. Each week we're going to publish a new article with a corresponding video. Tonight's the opening, or this video is the opening theme video, opening article and video in the series, the first in a series of 10. All right. The first star we're going to talk about is the star Arcturus. Now, quoting from the article that we just published earlier today, to study Arcturus is to study ourselves and the long-term evolution of our own star and how it will affect our solar system over the intervening 2.5 billion years between now and when our sun will evolve to become a red giant star, an evolved star identical in every aspect to how Arcturus is today. Arcturus is one solar mass. It's the equivalent mass of the sun, but it's evolved to an enormous size, having exhausted its internal complement of hydrogen. If we compare the sun to Arcturus, for example, and to even a larger star, Antares, which is among the 10 brightest, and perhaps we'll get to that in 2 or 3 weeks in one of those future installments of the 10 brightest stars, Arcturus compares to the sun. It's enormous compared to the sun. Here's the sun at less than 7 million kilometers in size, in diameter. Beg your pardon, in radius. And Arcturus, 20 million kilometers. It's over 28 times the size of the sun, with 28 solar radii. Okay? Antares is 300 million kilometers. The big difference between Antares and Arcturus, Antares is a high mass star. Arcturus is a solar mass star. Antares has much more mass than Arcturus does, and the sun as well. So, a size comparison, this is what we'd see. All right, the sun is a point here, a pinpoint, compared to Arcturus here, which is the size of a penny. And here's Antares, probably the size of a grapefruit or a small watermelon by comparison. So that's a size scale. This is very instructive. Superimposed Arcturus, where the sun was, you saw the enormous change in size, and consequently the change in luminosity, much more energy because of the larger surface area. Although it's cooler than the sun, the surface area is much larger, and hence the energy output and the energy delivered is going to be much greater. Okay, it's the same mass as the sun, but 2.5 billion years older, or 7.1 billion years old. So the star first burned bright 7.1 billion years ago. All right, the one aspect of any star that principally affects its evolution is its mass. The mass of a star determines its lifespan, its luminosity, temperature, and evolution from a nascent protostar to its ultimate end state. In the case of Arcturus and our sun, that end state will be a white dwarf star. Now we open up with a rather peaceful view of our solar system in its current form, with the sun at the center and the major planets in orbit around the sun. And this, I should put a plug in here for the Universe Sandbox. This is an incredibly powerful digital tool that allows you to reproduce scenarios astrophysical scenarios that you wouldn't normally be able to observe or see in nature. What we're going to do here is we're going to replace the sun with the star Arcturus and see what happens, and see what happens to the Earth, and what the solar system would look like if the planet survived that long, for another 2.5 billion years, what the solar system will look like at 7.1 billion years of age. Currently, its age is 4.5 billion years. So let's do that. Let's begin. Choose the sun. What we want to do is replace the sun with the star Antares. Arcturus, excuse me. Arcturus, right here. Replace. Now, look what's changed. It's changed dramatically. Okay? Because the sun is, that star is the same mass as the sun, the planetary positions and the orbital speeds aren't really going to change. What's going to change is the amount of energy that each of the planets will receive. Much more, enormous amounts of energy, much more than they receive today. As an example, let's take a look at the Earth. We'll stop the simulation and we'll choose the Earth. Earth is here. You can see how red hot it is here. 790 degrees C, or 1453 Fahrenheit. That's close to the melting point. That's twice the melting point of lead, which is 700 degrees. It's an inferno. So needless to say, all life on Earth will be gone at this point. In a scant 2.5 billion years from now, this is what our sun will look like at that time. And this is the star Arcturus. And this is what I meant when I said earlier in our article, to study ourselves and the long-term evolution of our own star and how it will affect our solar system over the intervening 2.5 billion years. A common theme that runs through all of this discussion is the idea of change, how close we are metaphorically here on Earth in the present day with our own sun and our solar system to Arcturus, and how distant we are at the same time. We're separated in time and space from Arcturus by 2.5 billion years, and in space by 40 light years. Arcturus is 40 light years distant, so the light we see from Arcturus tonight, shimmering, warm and bright, that light left the star 40 years ago. So if you have a newborn babe tonight, just think the light coming from Arcturus, the light leaving Arcturus tonight will arrive 40 years later when that child is 40 years old. So it's a message in time, like you put a message in a bottle and put it into the sea, it goes across the sea, someone picks it up. But in this case, instead of crossing the ocean, it's going to cross 40 years in time. So an interesting idea would be to write a little happy birthday note to your baby tonight, put it in the bottle, put it away for 40 years, and give it to him, if you're still around 40 years later, and give it to him. In 40 years, when he's 40, he or she is 40 years old, and that would be a gift from Arcturus and you. Okay, so anyway, getting back to our simulation here, let's take a look at Venus. Venus is normally it's an inferno today. What will it be like in 2.5 billion years hence? Just shy of 2,000 degrees centigrade, or almost 3,500 degrees Fahrenheit. It probably would be a molten surface at that point. Okay, so the planets, the solar system, although the star is just one mass, so the orbits are not going to change that much in terms of orbital speed and distance from the star. The temperatures are enormous. So, needless to say, there'll be no life left here in 2.5 billion years. Okay, on Earth. That was Venus. Mars. In fact, I ran this simulation earlier. The planet Saturn at 10 astronomical units from the Sun, a paltry 7 below 0 centigrade, or 17 degrees. So at planet Saturn right now, it's about minus 180 centigrade. Okay? Now with the Sun, having replaced the Sun with Arcturus, Saturn is the first planet in our solar system where the temperatures are what they are here on Earth right now. Okay? So that's what happens. That's what will happen in 2.5 billion years when the Sun is aged out to 7.1 billion years. Now let's take a look at where Arcturus is in the night sky. Okay, here we see a rather nice view of the northwest sky. It's 10:30 at night now, July 27th. Okay, we have the Big Dipper right here. The Big Dipper is not a constellation in its own right. It's what we call an asterism, or a group of stars that has a familiar pattern. Okay, so I'm going to turn on the constellations, the lines rather, and the labels. See, here's Ursa Major, the Great Bear. Now, if we follow this arc in the handle, the Big Dipper, we can arc right to Arcturus. Also note, in the sky tonight, we have the first quarter moon, very nicely placed in the western sky. Okay, so we arc to Arcturus. Okay, and if it were earlier in the sky, earlier in the evening, we could speed to Spica. Spica's right down here. Spica's the brightest star in Vera the Virgin. Okay, so we arc to Arcturus right here, and we speed to Spica. So that's how we find this first of the 10 brightest stars in our sky, Arcturus. Okay. Before we close this video out, I would like to share something here with everybody. Located very close to Arcturus, in the same constellation, Bootes the herdsman. In fact, before we show you this, let's go back, turn on the constellations once again. We can show you what we have here. That's Bootes the herdsman, right here. Turn on the labels. It's a giant herdsman, right here. We arc to Arcturus, and we speed to Spica. Okay, Spica is a spring star, and it's a bright star, but not considered one of the 10 brightest. Okay, so maybe we'll come back to Spica at another time. Okay, now what I'd like to do here is go back and share this image that I acquired some years ago through a 20 centimeter reflecting telescope. This is Messier 3. Messier 3 is a globular star cluster that's about 34,000 light years away. So those tiny little pinpoints of light that you see right in here, the light that's producing this image left that object 34,000 years ago, basically 22,500 years before the end of the last ice age. Okay, it's a very old object, very distant object. And what's so significant within the context of this broader discussion about Arcturus is that those tiny pinpoints of light that you see here, those stars are the brightest stars in that cluster, and they're stars almost identical to Arcturus. So if we go here, we go and we have Arcturus warm and bright and inviting in our late summer sky, and we go back to this image. These stars here are at the threshold of visibility with a 20 centimeter telescope. Okay, limiting magnitude on that telescope is about 14th magnitude, which is a topic that we can get to in another video when I talk about it briefly in the article. The visual threshold for the human vision, human eyesight, is about magnitude 6.5. Even under the darkest conditions anywhere on the Earth, you're not going to be able to see stars that are fainter than magnitude 6.5. The brightest stars we see here are about magnitude 12.5 or 13. Those stars are identical to Arcturus, the same star we see right here, so warm and inviting, only 40 light years away, but now at the limit of visibility at 34,000 light years here. These stars too, by the way, I might add, are among the oldest stars in the universe. Okay, globular star clusters contain, it's a very, very unique and particular population of stars. Some of these stars date back to the very early parts of our universe, when maybe at least 10 billion years. Many of them are 10 billion years old. Some of them are as young as 7.1 billion years, which is the age of Arcturus, and some of them are much older, 10 billion years. But Arcturus, that beautiful, bright, inviting star that we see warm in our sky, shimmering like a ruby red. To find M3, Messier 3, named in honor of Charles Messier, an 18th century French astronomer who was interested in looking at comets or finding comets. So he made an exclusion list of objects that were not comets, and so henceforth, anytime he would point his telescope in that part of the sky and locate an object, and if it was in his catalog, he wasn't a comet, he would move on in his quest for comets. So the Messier catalog contains 110 objects. Messier 3, a globular star cluster, is the third entry in his catalog of non-cometary objects. So how do we find it? Let's go to Stellarium once again. Control F. Open up the search tool. Type M3, and it's going to find it for us right here, right in the constellation of Bootes, right next to Arcturus. Okay, do that again. M3. Right there. Just to the north and west of Arcturus. There it is, just to the northwest of Arcturus, right here, Messier 3. Highlight Arcturus, kind of it's a signpost. We'll find Messier 3, you type in M3 in the search tool, here. And there it is, in that little square, Messier 3. Okay, as you can see, it's just to the northwest of Arcturus. A good pair of binoculars, you'll be able to see it, although you would not be able to resolve any of the stars, even the brightest stars, as we discussed earlier. You need a telescope for that. You would be able to spot it as a bright patch of light against the sky with a good pair of binoculars. Okay, again, you can use the Big Dipper with the tail of Ursa Major to find both Arcturus and M3 right here. Okay, everybody. That concludes this first video in an installment of 10 videos. Each one will be 10 weeks. The entire series will be 10 weeks in length. This is the first installment, or the first week, the first video, and the first article. I hope everybody enjoys this, finds it useful. Oh, I might add also that a new feature added to our website, you might want to check out if you're so inclined. On the home page, click the blue bar. That's going to launch an interactive tool that uses Stellarium, but Stellarium on the web. Okay, coming up soon. Here it is, courtesy of Stellarium. Stellarium Web. It's fully interactive. When you launch it, it automatically defaults to the evening sky, as you'll see in a moment. See, right here. Here's the Big Dipper, right here. We just saw it. Point to stars, point to Polaris, the North Star, and so forth. This is looking north, and you would navigate here as we can do with the regular Stellarium desktop. You would navigate with the arrows, or the keyboard arrows, and so forth. That's a new feature here on Astronomy for Change. It's a free interactive Sky Tonight portal, courtesy of Stellarium. Okay, hope everybody enjoyed this video, found it educational and useful. Any comments or questions, please feel free to leave them in the comments section. And please stay tuned and make sure you check our website out, join our mailing list, find out what's new and noteworthy here at Astronomy for Change, and check out next week's the next star in our series of the 10 Brightest Stars. Until next time, everybody, take care and stay well.